Welcome back to Science Modernizers. In this video, we are going to see how to integrate the integral of 1 divided by the cosine of x dx. So stay tuned as we proceed the video. So to begin with, we are going to multiply this integral with by the cosine of x both on the numerator and the denominator. That is a form of rationalization, and what we get is I will be the integral of cos x divided by cos squared x. But cos squared x from the Pythagorean identity, cos squared x plus sine squared x equals to 1, this cos squared x can be expressed in terms of sine as 1 minus sine squared of x. And therefore, changing variables, we get, if we let u to be sine x, then du is going to be cos x dx, and replacing this into our integral, we get that's the integral of cos x dx, the integral of cos x dx. Since cos x dx is already du, so we are just going to replace cos x dx by du, and sine x is u, implying that sine square x is going to be u squared, and this basically gives us a standard integral, which is tan inverse of u plus the constant of integration c. But what's u? But u was a sine x, and so we get that I will be equal to tan inverse of sine x plus the constant of integration c. Now, this can be further simplified as, that is, using the definition of tan x, in terms of natural logarithm, I will be equal to a half times the natural logarithm of 1 plus sine x divided by 1 minus sine x plus a constant of integration c, where the absolute value of sine x should normally be less than 1, always be less than 1. So as you see, I is equal to a half times the natural logarithm of 1 plus sine x divided by 1 minus sine x plus a constant of integration c, and as we said, sine x, the absolute value of sine x should be less than 1. So what if we see another way to simplify this result, and if we consider just this function that is found inside the natural logarithmic function, that is 1 plus sine x divided by 1 minus sine x, we can actually simplify that by rationalizing this function, that is multiplying the numerator and the denominator by the conjugate of the denominator as seen on the screen. So basically, the conjugate of 1 minus sine x is 1 plus sine x. So we are doing this in order to simplify this rational function given to us, and this gives us, if you expand what is above, you clearly observe that this is the expansion of 1 plus sine x all squared, and it is the same as 1 plus 2 sine x plus sine squared x divided by what is below is the difference between two squares, that's the difference of two squares, and if you expand, we are going to get 1 minus sine squared x. And simplifying more, we get rearranging it, we have it in the form sine squared x plus 2 sine x plus 1 divided by cos squared x. But since this function, the function on the numerator share, all the functions on the numerator share a common denominator, then we can be able to split, saying that we can write it down as sine squared x divided by cos squared x plus 2 sine x divided by cos squared x plus 1 divided by cos squared x, as seen in this statement. So with this said, we clearly see that this is the expression of tan squared x, and this is the expression of 2 tan x sec x, and this is the expression of sec squared x. So basically, we see that this is a perfect square, that is tan x plus sec x, all of that squared. And so if we now replace this statement in the integral, so I will be equal to a half times the natural logarithm of tan x plus sec x, where tan x plus sec x all squared is similar to 1 plus sine x divided by 1 minus sine x. And from the laws of logarithm, these two shall come down, and therefore the 2 shall be simplified with this other 2, where I will be equal to natural logarithm of tan x plus sec x plus a constant of integration c. So this gives us another possible result to that same integral. So thanks for watching. Please do not forget to like, share and subscribe. See us in the next video. Stay blessed. Science modernizers, modernizing the educational world.